Alas, poor Yorick. No, do you need a hand with programming? I tell you, yeah, okay. Cutting edge programming languages. Oh my God. Today on SDL, we are going to talk. Well, it may just be me. Me is going to talk about programming languages because there's a lot of them. They've been around a long time, and everybody's always asking me what languages should they learn. So I'm going to tell you a little bit about my opinion, which is, you know, invaluable to you. So stick around.
This is a Security Weekly production.
Welcome to Secure Digital Life. If your users are going to keep putting risky stuff on your machine, you're screwed. So Tom can help us understand the complexity of blockchain.
I was reading through the show notes, man.
Oof. In binary, it would be 001. Who cares? But it's probably not significant anyway. Like you're looking out through the HAL dot, you know, like,
oh,
hey Dave.
It's like Sims, but with, you know,
it would be like Sims
instead of AI. It's only.
Accredited by Microsoft, Cisco, NetApp, IDLE, Oracle, and EC Council, QuickStart delivers high-impact, low-cost IT training through its cognitive learning platform in multiple domains. With QuickStart, you get an ever-growing catalog of courses, self-paced courses offered through a monthly subscription, virtual classrooms offered through an annual subscription, peer-to-peer learning, mentoring, official courses, certified instructors, hands-on labs, and more. For more information, visit www.quickstart.com. Use coupon code PAUL20 to get 20% off on all cybersecurity courses. QuickStart, creating world-class technologists. Halloween coming up already. Check out our on-demand material. Some of our previously recorded webcasts are now available on demand at securityweekly.com/on-demand. DerbyCon is holding its first time ever, mental health and wellness workshop. To support their efforts, please go to https://www.derbycon.com/wellness. That's a new and innovative kind of thing to be doing. Good job, DerbyCon. I, Doug, will be doing interviews at Microsoft Ignite in Orlando this month, which is actually next week. So it's at the end of this month. And Mark and I will be down there doing interviews. So if you're going to be there and you want to do an interview with us on site, if you will let me know ASAP, I can put you on our interview schedule for Microsoft Ignite in Orlando at the Convention Center next week. So we'll be there all week doing that stuff. And there you have it. So, yeah, I've got props. So today we can play with props or whatever. I don't. This is scary. I'm not going to touch that anymore. I'm going to put that back with the severed hand on the table. We'll leave it with the severed hand. So I think that'll work probably best. Today I'm going to talk about programming languages because I get asked a lot. So a lot of you have written me and said, you know, what's my opinion? What do you think? What should I learn if I was going to learn this and whatever? So I thought I would talk a little bit about programming languages for you and give you some opinions on how you can maybe better find the language that you need to learn, because you probably should learn one. The first commercially available language that ever came out was called Fortran, which stood for Formula Translator, and it was a very long-lived beast of a language that actually first appeared on the scene in 1956, if you can imagine that. I learned Fortran 2 in 1977, and I learned Fortran 77 in 1981. They were very different. All those old languages evolved from very primitive things into modern incarnations. Fortran today still exists. If you go looking for it or shop it around, you'll actually see requests, but very, very few. And I did some research on this before I did the show. You know, look, Ada Lovelace, if you ever wondered who Ada Lovelace was, she wrote a translation about Babbage's analytics engine in the 19th century. So that was probably the first time somebody was actually starting to talk about coding languages, because Charles Babbage was developing analog approaches to actually coding machines way back in the 19th century. Grace Hopper. If you don't know who Grace Hopper is, you should, because Grace Hopper, besides being the first female admiral in the United States Navy, also was a very famous pioneer of computer programming languages. And she designed a language called Flowmatic in the 1950s, and it later became commercially called COBOL. And COBOL, which was one of the original languages that came out in the 50s and 60s, is still out there today. You can still find jobs requesting people to do COBOL, although again, this is vastly depleted from what it used to be. But COBOL used to be a very, very big language, but it's still out there today, and you can see requests for it. McCarthy invented Lisp, LISP, in 1956 as well. That's still around. There's still people looking for Lisp coders out there. That was a artificial intelligence language, sort of. It's a really cool language if you've never fooled with things like that. I used to really like Lisp a lot, and I wrote a lot of code in Lisp, so I enjoyed it. And that was in the 90s. Today, it still exists. You can get it. And I could go on and on and on for the rest of the show about all these historical languages and the many, many, many different ones. There are, if you've ever seen, there's a big chart you can find online that shows all the programming languages and all their derivative languages and all how they evolved and all this, just, and it's like just gigantic table of things. And there's new ones coming out. So even today, we see new languages that are around. So I want to tell you about a few basic ones and talk about that a little bit. The lowest levels of coding that ever really existed was called machine language, and machine language was something that people did way back in the 40s and 50s, where they were just literally coding in zeros and ones, and it was not friendly and it was hard to use. The thing that was put on top of that very quickly was called assembler. And so assembler was a language that is very low level, and it basically is writing instructions directly to the CPU. So this is what all languages ultimately do. So eventually, no matter what language you use, it's going to be in machine code. But at some level, assembler was a way to write very fast, very agile code that was directly into the processor. And early on, the one time I ever taught assembler, I was teaching it for graphics. And the reason we were using assembler for graphics was because it was so fast. And this was back in like the late 90s. I was teaching like some graphics programming stuff, and people were interested in how they code this. And back then, that was one way that graphics were coded. A lot of early graphics were coded in assembler. And please, programming historians, I'm not trying to be, cover the whole thing or the history of programming. This is just sort of my take on it. So I realized there were other things there. There were other options, but this was just where I was. But today, we still see that grouping in the types of programming languages that are out there. So there are essentially right now about 4 types of programming languages if you want to try to categorize them a little bit. One of them is low-level languages. So low-level languages are still going to include machine code and assembler. So you will see people coding in that when they're doing engineering applications, they're doing chipsets, they're doing all kinds of low-level stuff. When you need something that's small and fast, assembler, machine language kind of stuff is a place to be. When you're coding on a chip, and again, some of this is evolved, and I know that it's not all-inclusive, but if you're coding on a chip, a lot of times you may be coding in these low-level languages. There are also high-level languages. And high-level compiled languages are things that most people are familiar with. So when you start hearing people talk about languages, a lot of times you're talking about high-level compiled language. So like video games are typically written in high-level compiled languages. Applications are written in high-level compiled languages. And these are languages that are further away from that machine code. So that means they have more human-oriented instructions. They're easier to read. They're easier for poor, pathetic humans to actually sit down and write something. There are also high-level parsed languages. And parsed languages get a lot of grief. And especially from older coders like me, who originally saw parsed languages as kind of a tool that you use, not a real programming language. But today, that's not really true anymore, and we'll talk about some of those. And then there are also web-based languages. So these are browser-enabled languages. And there are some places where these stuff's starting to overlap, and you're starting to something like, I need another hand. So if something like that, where they're all starting to overlap. into each other. So a compiler, then, and this is just some terminology for you, a compiler is a tool which takes instructions that are written in something. So you could write them in assembler, you could write them in C, you could write them in Java or whatever. And it takes those instructions and it adds all, when you compile it, it reaches out, it pulls all the instruction sets together, and it builds a big executable file. And that executable file, if you've ever seen like a .exe file or any of those kind of things, those are compiled collections of libraries and all these kind of pieces of things that all fall into this category of a compiler object. And then when that thing runs, it executes instructions to the CPU. So that's what that is. A parsed language then is really just a file, usually a text file even, of instructions. So you could, in a parsed language, just sit down at the command line and type those same instructions and cause them to actually do the same thing. So people have often called these scripting languages or scripts, and then that's really what they are. So if you go to the command line and write a script, like people used to write batch programs in DOS, or people in Linux write bash scripts and things like that, those are parsed languages that can execute instructions. A lot of older programmers don't, they always have this bias built in against parsed languages because they were slower. They often didn't have the same features as compiled languages. But today, that's not really true. The other thing you need to do programming is an IDE. So an IDE is a piece of software that helps you organize your code. So there are tons of these things out there. A lot of them are free. You can download a coding IDE for any language that I've ever heard of and put that on your machine, usually for free, and you can do that. Another term I want to introduce before I go and talk about the languages is an API. If you watch other shows, you'll hear people talking about APIs, or I always say APIs, and people don't like me to say that, but I always do anyway. But an API is a library. So sometimes another person wrote a bunch of things that, why keep reinventing the wheel? If you need a program that will calculate something, or it will do something like a common library, like a common API, and C is math, so that you can have engineering functions and things like that if you want to do those things. There are always common API subroutine libraries that contain all kinds of stuff. One of the things you hear a lot of people talk about is about how APIs impact security. Because when you use an API to help you with your code, if you're writing a game, you may get an API that has pre-built characters in it so that you don't have to code all that. You just want to put a character on the screen that moves around. Okay. There you go. You could download it, but the security risk is that you don't know what's in there necessarily. So a lot of times APIs are, built by someone else. You don't necessarily go through them a line at a time and figure that out. And the other problem with APIs as you start getting into coding is that be sure and read your licenses for APIs. Because API licensing can be weird, and you say, well, I found this API online, I downloaded it, and I used it in my product. And it turns out that when you write the next Facebook or you write the next World of Warcraft, and it turns out you use somebody else's library and they didn't allow you to use it, they didn't care about you when your game was worthless, but they are going to care about you a lot when it's worth millions of dollars. Just ask Zuckerberg about the Winklevoss twins, or watch that movie even, and you can see. And suddenly the lawyers all start circling around. Web languages then are designed to be executed in a browser window. So they take advantage of a lot of different things and a lot of different stuff that exists. Like we have all these languages, like Flash is a really unpopular one that some people still use. There are things like JavaScript and other stuff that you can use to actually take advantage of the browser window's capabilities to pull in code from all across the internet. So a lot of different things you can do out there with programming languages in the modern age. So everywhere from just low-level stuff that you want to code a chipset or a Raspberry Pi, which is, if you don't know what that is, it's a little, you can buy a little computer very cheaply and you can write code on it. You could write that code in assembler. Of course, you can also write it in other more advanced languages if you don't want to get into assembler coding, which you probably don't. So let's talk about popular languages then. What I did was I sat down with a tool that doesn't sponsor me, so I won't even say what it was, but it's a tool that if you want to sponsor me, guys, that'd be cool. But But I sat down with a job search tool and I started typing in, and this was not a scientific study. It was not an academic research project. It was just me sitting at my computer, you know, typing some stuff in to see what would happen. And I typed in a lot of languages that I knew about and I'd seen through the years, and I typed in some ones that I know are popular. And I was just looking at how many jobs required those languages. So how many jobs were listed that said something on them like X or Y or COBOL or whatever. And I was looking at what the more popular ones were. And then I have, of course, my own opinion about this stuff. Well, by far, the language that came up with the most job entries that, just on this totally non-scientific research. So this was just, you know, and I might have, yeah, I was drinking coffee, I swear. That's what's in here, just in case you were wondering. But at least on this show. But Java was the one that came up the most. So, and again, it was non-scientific, so I didn't do an exhaustive study of weird ancient languages just to happen to see if, you know, Wattball had made a resurgence. But actually, I did. But Java came up a lot, and Java's been around a long time. It's owned by Sun. So, but it's free, so you can download it. Most people have Java installed on their computers because Java is so ubiquitous these days. And Java is a platform-independent product, which was one of their big deals all along because other products required a compiler for that platform, but Java was supposedly ran in a machine, a virtual machine of sorts on the local machine, and therefore it had its own virtual CPU, kind of. And I'm taking some liberties with the engineering of it, so engineers, I'm sorry. But that Java became this very popular mechanism to write all sorts of things from video games to applications and so on. And I've done Java. I have taught Java before. I personally find Java to be very clunky. And so now it's just opinion. And Java people, please don't send me hate mail. It's not necessary. I know you don't like me, but it's okay, really. Java is a very popular language. There's a lot of jobs out there for people that know Java. I think my biggest problem with Java and Java with new beginners was that it's just kind of overwhelming. And it has a lot of APIs. It has a lot of things that can be added to it and customized. So it's super crazy powerful, but it's also very challenging for people to learn right off the bat. There's a lot of derivatives of it. So you'll see things like J++ and J# and all kinds of strange things that are variants of Java, so that if you know Java, you can kind of adapt to that, but it's running in a custom IDE. You know, like Microsoft wants to have their own Java Visual Studio IDE arena, so they create their own versions of these things. And then their own versions like J# actually use Microsoft APIs, so it's really so that Java programmers can write code on Microsoft systems using Microsoft environments and take advantage of all the stuff Microsoft did. Obviously, the other big monster that's out there is C/C++. So C has been around a long time, and longer than Java, and a lot of stuff is written in C, and a lot of programming languages are written in C. And C itself was a pretty low-level language, and it is all-powerful. So if you want to be like the programming meta world, you know, supreme being in programming, you probably code in C. And C is fast, it's compiled, it is all-powerful. If you want to write your own programming language because you don't like the features of C, you can write that in C and then convert it over. So it's widely used. And C++ was a bolt-on to the original C language that added even more human-friendly components to it, as well as adding modern components to the old C language. So a lot of stuff that you see in C++ is going to be very similar to C. But again, C++ is another one of those languages that's so powerful and it's so big that a lot of times it kind of overwhelms beginners for that. Now, we still teach Java and C as entry-level languages at the university, and that's a pretty common thing. So our university computer science department teaches Java as a first language, and you can scale it down to that. When I was teaching computer science 1 and 2 in Colorado, I taught C and C++ as computer science introduction languages, and a lot of people dropped. I won't lie to you. A lot of people decided maybe they really did want to be a video game designer at that point when they saw what programming was really all about. But C++ and Java were probably the two biggies that are out there on the table right now. And I know some of you are saying, oh, but Doug, what about, and I'm like, I'm getting there. But in the compiled world, and this is where you're going to see games written and things like that, because the other advantage of compiled code is that you can't actually see how it works. You can decompile it, and I know there's all kinds of ways to hack it and break into it and extract things from it. But for basic use, most people cannot decompile a compiled object and extract the code from it. Sure, engineers can, sure, hackers can, but most people can't. So when people write application products for systems, they tend to write it in Java or C++ so they can compile it up. C#, you've probably heard that term. C# was Microsoft's version of C. They added all their Microsoft stuff in it just like they did with J# so that you could use it in Visual Studio and you could write, you know, all kinds of Microsoft code that takes advantage of the Microsoft operating system features that are there. So in that compile category, I would probably put down those two as the two most popular. I looked at a lot of other languages, like I did look at Fortran, which there were a few jobs out there. I did look at COBOL, there was a few jobs out there. But compared to Java and C, they really weren't in the same ballpark. I was actually surprised there was as many Fortran jobs as there were, but there was something like in the Java, and I won't swear to this, and the number could have changed since yesterday, but you know, Java had like 90,000 positions listed. Fortran had like 1,900, so you know, not very many overall. Now, if we start talking about parsed languages, so a little bit different thing. Parsed languages are very popular, and they're simpler in some ways. They also are very feature-rich in terms of what you can do with a system, because you can actually reach right into the system, and anything you could do at the command line, you can do in that parsed language. But in the modern age, they started adding to these parsed languages until they became full-fledged programming languages in their own right. So one of the ones that is very, very popular that I'm sure you've heard of, or if you haven't now, you will have, is Python. And Python was one of these things that had been around a while, but it really emerged today as a very, very popular language. It's parsed, so you don't compile it. You just write instructions, and you can do, you know, very simple things. You can actually use features of the operating system right there on the fly. But Python is super crazy powerful as well. And I just recently started using Python in my graduate course as the first language in this accelerated programming thing I teach. And I found it to be very rewarding. I'd done Python years ago, and I didn't like it very much then because I was a big C++ fan, and I felt like, you know, parsed languages. But today, when I use Python, I found it to be very powerful. I found it to be very useful, and I also found it that it had so many of the features of C++, but it was done in a way that was a lot friendlier. And I felt like learning it might be easier than C++ because it didn't seem to delve as much into strange syntax like C does. And it had just a friendlier feel to it. So maybe Python is a more user-friendly kind of way to get started. I looked, and there were tons of jobs for Python. I described it as C without all the challenges. There were things I didn't immediately learn how to do in Python, and I didn't try necessarily to do all the elaborate things I have done with C at some point in time. And some things seem to be missing, but they may actually be there. So again, Python people don't hate me. I really like Python, and I think it has a great deal of potential out there in the world. And then there are specialty languages. So if we want to dig down a little further, the internet meant that all of a sudden every computer on Earth has a browser on it. I don't know what that browser is, what browser you like. I won't even mention them. I will leave that up to you. But the browsers on your system support certain things. And we've seen some political controversies with them, like them refusing to support Flash because they didn't like it. And there was some of that kind of stuff. And there have been other controversies about it in terms of what's allowed and the security and all these kind of things. But browsers in general do support certain languages. And if they don't, you can install a plugin, which is what they call it on browsers, which is essentially going to be the processor for that particular language. Now, most of these languages that you see being used there are parsed languages. So they're just scripts. One of the most popular ones is called JavaScript. A lot of schools teach this. And JavaScript, which has very little to do with Java itself. JavaScript is something else. They just gave it the unfortunate name of JavaScript. I really think they should have called it something different, but hey, what am I going to do about it? And JavaScript is something that will run in a browser window, which means you can sit down with this parse tool and you can embed it in a web page. So that means when somebody clicks it, it will execute some instructions in that window. It's a way you can draw graphics on the screen by pulling in GIFs or things like that. You can. I wrote a game in it once that was just like a card game, so it would pull up pictures of playing cards, and in the back end of the JavaScript, you could write all that kind of stuff. It's parsed, though, which means that people can see how it works. They can extract the code, but you can write an interactive game pretty fast using JavaScript because you've got the browser already built. So because there's a browser there, you don't have to design all that piece to it. And again, I know you can do all that stuff with other languages too. The other biggie that I have dealt with most on the internet is PHP. And PHP is, again, it's an old language that's been around a long time, but it's really super crazy powerful. And when I first started dealing with the web and I first started trying to write web apps for people, the language that I chose to use was PHP because it was built into a lot of web servers. So if you have running Apache or IIS, which are the two most popular web servers, and I know there's other ones, but the two most popular ones that I have dealt with, you can just install PHP on those web servers, and then that code executes on the server. You can also force stuff to execute locally, but and again, that gets into another whole complication. So PHP, there are a lot of jobs for PHP developers out there, a lot of jobs for JavaScript developers out there. Better than that for me in the modern age is Ruby and Ruby on Rails. It was probably 2 years ago, I sort of sat down and said, I need to learn another programming language. I haven't done this. I want to learn more about it. And Ruby on Rails was what everyone told me I should play with. And so I got that, I installed it, and I started, I just sat down and immediately I said, I'm going to write a game because I like to code games and it's fun. And games have rules, so they're in many ways they're easy to code, because I know the rules of a simple game. So you take a card game, a dice game, a board game, whatever, they have rules that are pre-built, and you can sit down with those rules and sort of figure out what to do. And I just took a simple card game, the card game of Blackjack or 21, because I know the rules to it. It's a simple game. It doesn't have a lot of moving parts, and it has some very, very solid things there. You don't need an AI to write a Blackjack game. And Ruby on Rails was what I chose to write that in. And I found out that writing graphics in Ruby on Rails was a really, really easy thing to do compared to, say, writing graphics in C++. So I sat down and I learned Ruby on Rails. I liked it. It was a web-enabled language. It was free. It was fun to write in, and I enjoyed it. The only other language I'm going to mention to you today, and again, if your favorite language I didn't mention, I really do apologize. Write me a note and I'll talk about it some other time. The other language I want to mention to you is called SQL, which stands for Structured Query Language. Structured Query Language has been around forever. And it is a language that has a very specific purpose, so it's a specialty language. It is used to write queries to databases. And everything today is based on a database. So if you have a game, you store all the game moves and things in a database. If you have an application that processes data, you store all the tables in a database. Everything is managed on that back end like that because it's a very efficient way to do things. If you want to do that, regardless of the other language that you're using, whether you're using C++ or COBOL or you're using Ruby on Rails, you may need to use a back-end database to store your graphics, to store your links, to store all your information or your text or whatever, because you can put anything in a database. So SQL then becomes the back end of your code. So you really probably should start fooling with that. So I could literally sit here then for the rest of the day and we could probably list languages and come up with ones that have been around since, say, the 1940s when we first started seeing languages. So what should you do? I mean, that's sort of what the whole point of this was. Well, I recommend that you pick a language. I mean, so this is my recommendation. I'm going to give you some tips so you can come up with your own recommendation. I recommend that you sit down and you find a language that looks friendly and fun to you, like Ruby on Rails, Python, or maybe if you want to do a compiled language, C++. But probably more like Python, Ruby on Rails kind of stuff. And think of something that you want to code with it, and then just start looking it up. There are so many websites that explain code and have all these kind of things, but you probably need some basic skills. So you might want to get a primer or something from Cybrary or somewhere free so that you can actually sit down and learn some basic structured programming skills to get started. Because that's going to be the hard part, is just getting off the ground. But there's tons of free courses out there, or you can sign up for a course at community college or at the university or online or wherever works for you. But for you to make your own decision, which is a better thing for you to do, get on the internet, start looking at jobs that you're interested in. What do those jobs recommend that you know? If you're trying to get into cybersecurity, knowing C, knowing Python, knowing these basic languages is probably a very, very important thing. But are the jobs you're looking at saying you ought to know Ruby, or are they saying you ought to know C? And that's a big place for you to start, because if you'll sit down and look at those things, you can start pulling together into your backpack, what do I really need to know? And then you can focus your efforts in that kind of thing. The other thing you should look at on the jobs that you're seeking are what level of programming are they looking for. If those jobs are saying, you know, expert level, if they're saying, you know, significant experience in or something like that, that doesn't mean you sat down and you fiddled around with it a little bit at home. That means you've been doing it a lot. So like you've got a college degree in it, or you have done it as a professional or something, or as a consultant, or however you manage to do it. If it says preferred or desired, you know, that means, hey, you could play around with it some and say, yeah, I have a basic understanding about Ruby on Rails. I wouldn't claim to be an expert on Ruby on Rails, but I wrote, I wrote several programs in it. I feel like I understand how it works. I feel like I could get up to speed, but I wouldn't apply for a job saying we need an expert in Ruby on Rails. But I can certainly apply to be a sort of entry-level developer in that area. Be sure and look for words like preferred and required. Preferred means, you know, yeah, we'd like you to know that, but if it says required, then you better know it, because if they say they require you to know C++, very likely when you go into the interview, they're going to give you a test. Because when I interview people for programming jobs, which as a consultant I have done several times, and I used to do that at the bank, we gave people, you know, we handed them some code and said, here, debug this, you know, and if you were looking at it going, well, I know I said I was an expert, but, you know, yeah, you didn't get the job. If you want to be an application developer, computer science is probably a better place to be majoring and focusing your studies, because that's really where computer science is. If you want to be a low-level designer and you want to design new things and how they work, probably computer science engineering is where you want to be. But if you're into something like cybersecurity, cybersecurity doesn't rely so heavily on being a programmer as much as it relies on understanding programming languages. So you need to know how they work. I would really suggest you take some classes in that area, because it's going to be important at some point that you understand how programs work. What is a loop? How does it work? What is a query? What is an, you know, and all these things that you've heard me saying. You might want to learn how some of that stuff works, but you can certainly get those skills just by doing bash script. You can go on a Linux and get a bash script set up and start learning how to code. My other tip for you is learn an easy language. So Ruby, Python, things like that are so much easier, and there's lots and lots of fun stuff to code, which means you won't get so bogged down in weird syntax like pointers and vectors and all kinds of strange things in C++. And if you pull all that together, how do you do this? So how do you get started? Well, unlike the past, so the distant, dark past that some of us have been exposed to, today you can go online and get something like VirtualBox, and you've heard us say many times, get VirtualBox. You can get an image of Mint Linux or something like that, which all that's free. It costs you nothing except having a computer to work on. Put those two things on there. In Mint Linux, you can install an IDE. And there are a lot of free IDEs out there, and you can certainly Google through digging that up and say, okay, I've got an IDE I like Code Blocks is probably my favorite one. So code::blocks and it's free. You can put it on Mint Linux, and it's a nice GUI environment. You can write code, and it highlights those keywords, and it helps you with mistakes and helps you, test it and whatever thing like that. So if I just had to say what should you learn, I would say probably either learn Ruby and Python or Python and C++ or something like that. Learn Python to get started. Sit down, think of some fun things to code. How do I get started? Well, there's all kinds of examples. How do I put hello world on the screen? The classic example that I hate, so I always put something beside that. And then maybe expand it to write some basic stuff. Like, could you write, say, a really simple dice game? Like, just can you throw a dice and put it up on the screen? I mean, that's not complicated. There's no AI there. There's nothing really fancy or anything elaborate like that. You could do all that with Code Blocks, Mint Linux, and VirtualBox. That means you could code every one of those languages that I talked about in that environment. So get a compiler. You may have to get that for your system. But again, on Linux, all this stuff's free. You can get GCC, you can get VCC, you can get PHP, you can get Ruby, you can get all those things and put them in Code Blocks and just start coding. So at some point you'll want to study, but when you want to just get started, get some basics, fool around, have some fun. And then when you get stuck, that's when you maybe stop and take a class and say, I need to learn more. I need to know how recursions work. I need to know how vectors work, or whatever it is you're trying to learn. And that may be the place where you have to stop and sit down and do it. Thanks for listening to me rattle on about programming languages for 30 minutes. I hope it was helpful to you. Send in your comments and keep those cards and letters coming into SDL. Next week, I will be in Florida, so I won't see you, but we'll be back 2 weeks from now. Thanks a lot. See ya.